I have got this data from our formula student last year in 2018 formula student. It's probably 17. Yeah. So 2017 or 18. Yeah, it was 18. So they reported that the air temperature at these two different pressures, so 15 psi and 12 psi, so at these two different pressure level, the intake temperature, they said they found 230 and 210. And according to them, there was no significant change in volumetric flow rate. So, and then I couldn't figure out how they got this number. So I thought, let's test this, whether this report something wrong with it or not. As you know that the energy equation is P1 V1 by T1 is equal to P2 V2 by T2. If the volume is constant, so then we can just simply write P1 by T1 equal to P2 by T2. However, I would like to write this way. It's going to be easier to compare these. So T1 by P1 equal to T2 by P2. So let's first calculate this T1 by P1. So the temperature 1 was reported 230 degree Fahrenheit plus 460 degree ranking. So you have to use the absolute temperature and pressure. And then if it's 15 psi absolute gas pressure, then you got to convert that with 14.7 psi. So this ratio comes, I have got this ratio 23.23. So I have got this ratio 23.23. This should be same as this ratio. Let's see, plug this number. So T2 was 210 plus 460 degree ranking. So that's going to be in ranking. And then P2 was 12 psi plus 14.7. So I got that value is 25.09. So they're not same. So something wrong here. Now let's see what are the other possible combination. It could happen that they just simply did this 230 by 15, which I have found 15.33, or that is 210 by 12, which I have found 17.5. So that's not equal either. So that is not. Now let's see. Now they could just probably. So this is scenario 1, the correct scenario. That's the scenario 2, wrong. Scenario 3 is also wrong. They probably could didn't convert the temperature. However, they convert the pressure like that. So this is 7.74, and then 210 divided by 12 plus 14.7. I have got that 7.8. So this look like probably if they have calculated all of these value out of combination of the other three, then this is the possible thing they might have done, because in this case I have got the same ratio. So they probably did not convert this Fahrenheit to ranking. They only convert this pressure. Now another scenario could be these numbers are not measured. They were directly got from some kind of instrument, so they didn't really calculate one of them from the other three. So if they measure all of them, then definitely the flow rate is different for sure. So however, I asked them the question, is the flow rate different? They said no, they're kind of same in both temperatures. So either the flow rate is different, or this is the equation that was used. So I thought this should clarify some of the conversion mistake.